Here we have AP calculus AB problem. Okay, let's go to the question. If 7x positive y equals to k is the equation of a line tangent to the graph of y equals to 9x positive 1 over x square, what is the value of k? Okay, here this is the equation of the curve. For this curve, we have the equation of the tangent line, that is 7x positive y equals to k. Okay, now to get the slope of this tangent line, what we can do is we can write this equation in slope intercept form, that is y equals to mx positive b. Okay, now to get this equation in this form, y equals to mx positive b, slope intercept form, we just have to subtract 7x from both sides. When I do so, I am getting y equals to negative 7x positive k. I just subtracted 7x from both sides. Okay, now I got this equation in slope intercept form, that is y equals to mx positive b. So here m is the slope of the line. Instead of m, we have negative 7 in our equation, equation of the tangent line. So clearly the slope is equal to what? Slope is equal to negative 7. Okay, now let's consider the equation of the curve we have over here. Okay, from the equation of the curve, if I want to get the slope of the tangent line, what I have to do is I have to get the derivative. That is, I have to get the result of dy over dx. So the dy over dx, we get it from the equation of the curve over here, gives the slope of the tangent line. Okay, now let me take this equation as it is. It is y equals to 9x positive 1 over x square. Okay, now I'm going to find dy over dx. It is a derivative with respect to x. Before we find derivative, let me make some adjustment on the right side. That is, I'm going to move this x second part to numerator. Let me do it. So when I move it, so it will be multiplied by this 1 in numerator. Whenever I move a particular term from numerator to denominator or denominator to numerator, so the exponent will change its sign. So here it's already positive 2. When it is moved to the numerator, the exponent 2 will become negative. Then we get x to the negative second power. So it is multiplied by 1. Still we get x to the negative second power. Okay, now we can find derivative of this one, that is dy over dx. So here 9 is a constant multiplied by the variable. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is and I have to get derivative of the variable alone. When I find derivative of this x with respect to x, it will just become 1. Okay, now let's get derivative of this one using the power of derivative. So that is, we have to bring this exponent in front of the variable and subtract 1 from the exponent. Okay, when I move this exponent negative in front of the variable, already it's positive. Positive times negative will become negative 2 x to the power of, now I have to subtract 1 from the exponent. So when I subtract 1 from the exponent, I am getting negative 2, negative 1, so which becomes negative 3. Okay, now let's do some simplification over here. Dy over dx equals to 9 times 1 is 9, negative 2, and here we have the exponent negative. So to make this exponent positive, we have to move this term to denominator. Then I'm getting 2 over x to the third power. Okay, now I got the derivative dy over dx from the equation of the curve. Actually, the result of dy over dx here represents the slope of the tangent line. Already we got the slope of the tangent line by writing the given equation of tangent line in slope intercept form, that is negative 7. So this 9 negative 2 over x cube and this negative 7, now both of them are represent the same stuff, that is the slope of the tangent line. Since both of them represent the same stuff, we can equate them. That is 9 negative 2 over x cube equals to negative 7. Okay, now we have to solve for x in this equation. For that, let me subtract 9 from both sides. When I do so, this 9, negative 9 will cancel. Then I'm getting negative 2 over x to the third power equals to negative 16 on the right side. Okay, now what I can do is I can multiply both sides of this equation by negative 1 to get out the negative sign over here and here. So when I multiply this one by negative 1, I'm getting 2 over x to the third power. When I multiply this one by negative 1, I'm just getting positive 16. Okay, now let me take reciprocal on both sides to get the variable in numerator. When I take reciprocal for this one, I'm getting x to the third power over 2. And when I take reciprocal for the 16, I'm getting 1 over 16. Okay, now let me multiply both sides of this equation by 2 to get up the denominator on the left side. This 2 will cancel out. 2 goes into 2 1 times, 2 goes into 16, 8 times. Then I'm getting x to the third power equals to 1 over 8. Okay, now to solve for x, I have to get up this cube over here. For that, we have to take a cube root on both sides. Let me do it. So let me take a cube root on both sides. When I take cube root on both sides, a cube root and cube will cancel out. I'm just getting x on the left side. When I take cube root of the numerator 1, I'm still getting 1. And we know that the cube root of 8 is just 2. Okay, now I got the value of x, that is x equals to 1 over 2. Actually, this is 1 over 2 is the value of the exponent at the point of tangency. For example, let me draw the curve over here. And so here we have the tangent line. Tangent line means a line which touches a curve at a particular point. At this particular point, the x coordinate is 1 over 2. And what is the y coordinate? That we have to find. Since we have the point of tangency on both the tangent line and the graph we have over here, what we can do is we can plug in this value 1 over 2 for x and to get the y coordinate at the point of tangent C. Okay, now let me erase the stuff and plug in this 1 over 2 for x over here to get the value of y. Let me erase the stuff. Okay, let me take the equation of the curve. Y is equal to 9x positive 1 over x square. Now let me plug in x equals to 1 over 2. Then I'm getting 9 times 1 over 2 positive 1 over 2 the whole square. Then I'm getting y equals to 9 times 1 over 2 is just 9 over 2 positive 1 over this 1 over 2 the whole square the result of this one is 1/4. Okay, now let's do some simplification over here. Then we get y equals to 9 over 2 positive, and so here 1 is divided by 1/4. The simplification of this one is just 4. Then we get y equals to, now to add this fraction and integer, we have to multiply this integer 4 by the denominator of the fraction. Once I'm done with the multiplication, I can take this 2 as a common denominator. That is, I multiplied this 4 by 2. Now I took this 2 as a common denominator. Then I got y equals to 17 over 2. Okay, now I got the point of tangency. That is the point at where the curve and the tangent line touch each other. So here already we got the x coordinate 1 over 2. Now I got the y coordinate 17 over 2. Okay, since the point of tangency we have on both the tangent line and curve, we can plug in this point into this equation of tangent line to get the value of k. That is, we have to plug in this x coordinate 1 over 2 for x over here and y coordinate 17 over 2 for y over here. Okay, let me do it. 7 times 1 over 2 positive. For y, we can plug in the y coordinate 17 over 2 equals to k. 7 times 1 over 2 can be written as 7 over 2 positive 17 over 2, which is equal to k. Now we have the common denominator. We can add the numerator 7 and positive 7 equals to k. Then we get 24 over 2 equals to k. When I divide 24 by 2, I am getting 12. So I got the value of k. The value of k is 12. We find 12 in answer choice C. The correct answer choice for this question is C.